And the hospital IT staff was like, guys, we have a lot better to do right now. And we only heard that afterwards. But the nurses were like, guys, we don't even use your phones anymore. They're so bad that we try to get to a window where we have cell coverage. We just shout in the corridors. Anything is working better than your phone.
Wow, pretty bad feedback at this point.
Depending on the way you hold the phone, you put your hand on the antenna and the coverage is really not the same.
You're holding it wrong.
Exactly.
What they were saying.
They were always right under an access point because there were access points pretty much everywhere.
Welcome to Cisco Tech Stories, a podcast with real-life stories from real-life engineers. Your hosts are Nico and Tristan. In this story, a hospital is facing voice-over Wi-Fi call quality issues, impacting healthcare in the middle of the COVID pandemic. The Cisco A-team is called, but you cannot go on site. You cannot ask users for logs, you cannot talk to the users, you just have to fix it.
Hello and welcome to another episode of the Cisco Tech Stories podcast, where we tell amazing stories from our Cisco customer experience engineers from all around the world. This is Tristan, I'm technical leader in CX EMEA Service Provider Group, and joining me today is Nico, wireless wizard, magician of waves. Hello, Nico.
Hello, Tristan.
So, Nico, you told me you had a story where you are not allowed to go on site, ask for logs, or ask any question to the users. Yet, you managed to solve the issue, and I'm very intrigued about that. So, what was this about?
Yes, so just to put some context, this was end of 2020, when the pandemic was really hitting us really bad. And this happened in a hospital. This happened actually through several cases, service requests. I only came in at the end, but I'm going to reconstruct the story just for the storytelling. So a case is open, like happens a lot. Nurses and doctors here are the users, and they're using wireless Wi-Fi phones. Mm-hmm. So Cisco has several models. Back then, that was the Cisco 8821. It's just like a regular phone, but it uses Wi-Fi, right? That's for multiple reasons. When you can't have, for example, cellular coverage inside the hospital, you need to look to other solutions. And they were complaining about voice issues, right?
Voice issues, that's a bit vague. So what's that?
That's often how the descriptions get to us, right? So the first question the engineer asked was, okay, what do you mean? Do you have call drops? Because if the call is dropping, that could be a call manager control plane signaling issue. Was it just bad voice quality? Do you have sometimes voice gaps? Because sometimes the conversation is fine, but you have literally gaps with silences for 2-3 seconds, which could be simply a gap in the data forwarding, especially in Wi-Fi, because when you move around, you could have roaming and gaps, etc. So that could literally be anything. So we started to ask a lot of questions. The answer that came back, of course, is that the nurses have other things to do than to take note of everything that happens. And they basically said, everything is happening. We have voice gaps, bad quality. The calls are just terrible. It's like the worst experience ever.
The worst experience and at the worst time ever as well.
Exactly. So the engineer said, okay, let's ask plenty of vague and general questions because we need to isolate. That's the first thing we do in tech cases, right? We try to isolate because otherwise you could be going in any direction and you don't know if you're going right. Mm-hmm. So we asked many questions like how reproducible is it? Because if you can reproduce it on demand, we can ask you for logs and enable certain debugs. If it really happens randomly once in a blue moon, that's not easy to collect very specific logs. So we need to choose debugs that we can let run and hope to catch the issue over time. Mm-hmm. Does it happen more when you move around? And then we look at the roaming between access points? Or does it even happen when you're standing still next to a place where you have good signal? Something else we check in voice as well is the quality of service. So I don't know how familiar people are with quality of service. That's usually like a vague topic and people associate it with maybe WAN links, internet links. When you don't have enough bandwidth, you need to prioritize traffic over one over the other. In Wi-Fi, it's a little bit different. Quality of service is essential because it's a shared medium. You have 5, 10, 20, 50 users sometimes on the same access points. And it's like having 50 people in a room and you need to talk. It happens that people talk at the same time and then you need to detect the collision and try again, etc. Having quality of service means you can speak before the others. You have different timers and you can access the medium before others. So your risk of collision reduces really drastically. Doesn't mean you will never have collisions, but it happens much.
It's a bit like the traffic light on a crossroad. Let's make sure that you give right of way to the people who need it and the others just wait.
And while in a switch, that gives you a priority in the buffer level before other traffic. Here, you're avoiding collisions, which are extremely costly. So it's even more important in Wi-Fi. That's the reason. We asked, because we were working with a Cisco partner, we had IT people there, and they could not see the problem. So reproducibility is a bit dodgy. The answer we got from the nurses is some nurses report the issue sometimes per day, like once or more per day. It doesn't say if it's 1 per day for everyone. It could be 5 times per day. It could be some users never face the issue. It could be, it was extremely vague.
It's extremely vague and extremely random as well, it appears.
Yes, okay. Exactly. Yes. And we had the partner engineers who went on site and they said they never saw the problem. So that's really not helpful. Some context there is that it's also what happens to a lot of companies right now. The hospital didn't really have an IT staff, technical people. Their IT staff was more like managers. They had a lot of services, right? They used a lot of cloud services. They had a lot of applications, and they manage all of that. So they are technical to some extent, but there was no one to really go and take logs, no network engineer per se to do the job. And that went through a partner, which is usually something that works well. But in a hospital, you cannot access every area, easily. And when it's COVID, even less. So that was extra problems. So we tried the usual debugs, right? We take debugs. Something I realized over time, and I think we don't say enough about debugs, is that debugs are typically control plane debugs. What does that mean? Is they debug events. They debug the state machine. Is there anything that is happening? Here in Wi-Fi, are we kicking the client off from the wireless network? Is there a disconnection? That you would see in debugs. Mm-hmm. But the data traffic forwarding, that's something that does not go through the control plane.
And for a good reason. If you would be collecting those data plane debugs, that would be very verbose, right? It would spam the console and the buffers.
If you have a debug message for every packet you send, that's just not going to happen. That's not going to fly. Yeah. There's a good reason things are done like this. But that means if there's no particular event, but you're dropping packets, then you need to look at data plane, and you're looking more at statistics, packet captures, counters, not debugs per se. But so the debugs came back and they showed nothing special. So there was no particular event, no disconnection, no one getting upset, just business as usual from a control plane perspective.
So you mean that the issue was present, but nothing special in the control plane, right? That's what I mean.
Exactly. We were not seeing an issue in the debugs. Mm-hmm. Doesn't mean there's no issue, right? Just there's none in the control plane.
Yeah.
From the network perspective.
Yeah.
That's also something important you learn over time, right? The debugs, they tell you things, but it's from the perspective of the device where you collect them. It is not the absolute truth, right? Mm-hmm. So you have to say nothing is happening from control plane perspective from that device. You don't deny that there might be a problem, right? But okay, it's just one perspective you're checking. So the engineer there and the partner, they got really creative. And they said, well, the issue is that we need to know when the issue happens. Because we can let the debugs run, but you never know. You don't have the timestamp, right? And at first, they asked the nurses to note on a piece of paper the timestamp of the problem, where they had a voice quality issue. But the nurses honestly have better stuff to do, right?
They had one more patient, and that was this mobile phone in their hand.
Right. So they said, how about you press a key, right? I forgot if it was the star or the 5. They said, please press a key on your keypad when you have the issue. because in the logs, a key press is an event. So you see that in the debugs. So if you see a person, brutally pressing the 55555 button, that person is facing the issue and is kind of telling at that moment the person that this is when it happened.
Should have told them to press 911.
Well, yeah, okay. Maybe that would have got some false positive. So I thought that idea was brilliant, and I would have actually not thought about it. Problem is, the nurses really had better stuff to do, and we got a bunch of logs, and apparently no key was pressed. So that's annoying, but we don't have the heart to blame the nurses on that. They really had better to do. We had to get even more creative than that. So that's how that case was concluded. You're gonna say, "Oh, story over?" No.
That's a bit anticlimactic, actually, so far. No
Right.
conclusion.
So the engineer at that point said, "Okay, let's move to software releases that are recommended, right? Like for some known issues that could be similar, etc. And let's go to best practices." So there was a bit of some config tweaks. As you know, we have automation, right? And we check the configs, and we do have alerts on configs that are usually known to be not the most stable, etc. So there were recommendations made, but we honestly were stuck on a debugging perspective. We could not find the problem. And after those tweaks, the engineer asked, with a bit of hope, like, is the issue better now? And the partner was like, well, we don't know. We're not getting a lot of feedback from the hospital anymore. And the hospital IT staff was like, guys, we have a lot better to do right now. And we only heard that afterwards. But the nurses were like, guys, we don't even use your phones anymore. They're so bad that we try to get to a window where we have cell coverage. We just shout in the corridors. Anything is working better than your phones.
Wow. Pretty bad feedback at this point.
Exactly. But we didn't have the feedback then, right? The feedback was, oh yeah, we haven't heard more complaints. So that gives you the perspective of, you hear, oh yeah, there's no more complaints from the field. But actually on the field, there's so much complaints, people are not even using your products anymore. That's a lesson on how to get the real feedback, and not lack of feedback is not a feedback.
Indeed. So what happened next?
Well, the case got closed with the hope that, because I just said, right, we didn't get that feedback first. So it's like, okay, let us know if you face some more issues. And after that wave, things got, I'm not going to say a bit more stable, but okay, the COVID wave was getting slightly better. The hospital came back realizing, guys, we still have the problem. Why you did nothing? So another case was opened and everyone went ballistic. So this escalated pretty badly because we already opened the case. There was no breakthrough. Nothing was found. So that's how that came to me. And I got told, literally clear, black on white, you cannot go on site because, if you feel you would get better logs yourself, you're not coming on site. You cannot talk to the nurses. They're honestly fed up with Cisco engineers asking things. They really have better stuff to do. And basically, you're not going to go through many log collection cycles anymore because we're tired of that as well. Just fix the issue right now.
You need to solve it, but blind.
Exactly. And when I heard that, my heart was like, that's not going to happen. I'm sorry. Like, I'm out of magic. I would like to do magic, but I'm running out. I looked in my pockets. No magic there. So I was in a bad spot, right?
Indeed.
So what I do in those cases, like, okay, let's take a step back, right? Let's see all the steps that were done. And I could see that through some of the hints in the output we had, the previous Cisco engineer said, guys, it seems your coverage may not be top-notch everywhere. You may have areas where you don't have awesome Wi-Fi coverage. Please conduct a site survey to check on that, because it's not something we can check remotely, right? If you have signal in every physical location. But we do get hints in the counters that sometimes clients are connected to the network at a bad signal.
So that you're talking about the Wi-Fi reception from
Yes.
the mobile phone, the Wi-Fi client was really poor, right?
Exactly. Yeah. They were too far away from the access point, or there was an obstacle, or not enough access point.
An obstacle can be anything like a wall, a window,
Yes.
A metal.
In a hospital, there's a lot of machinery,
Yeah.
X-ray machine, shielded walls, thick doors. A lot of stuff can stop a signal, right? In an office space, usually walls are thinner. Obstacles would just be people and cabinets. In a hospital, you can have very thick walls. You can have very heavy metal machinery and all of that is gonna block your signal pretty quickly. So I'm like, let's jump on this, right? Let's verify this. And I asked, guys, did you do the site survey that was requested? And actually surprised, because this is a step that often gets skipped because it costs time and money. They did a site survey.
And what was the site survey about?
And the site survey result was that no particular issue found, right? So the people did their job. They did have suggestions, but there was no conclusion that there was a major problem. So that didn't look good for me.
Indeed, but that seems a bit conflicting with the information that you got. So
Yes.
who's right and who's wrong?
Yes. And at that moment, I also had a feedback from the partner, like, guys, we have the impression, so this happened since a year or so ago. And it just happens to be that a year ago, we refreshed the network. Before, we had also a Cisco Wi-Fi solution, but just the older wireless controller models and the older access point. It was Wi-Fi 4 generation, and they moved to Wi-Fi 6 on their AP, and the control also was the new generation. So they said, we believe the problem is with the new hardware, of course, right? That's the only change we see that could explain this, because we kind of put the APs exactly where the previous ones were, and we didn't change anything to the configuration from a concept perspective. So it has to be the new architecture. What I would do normally in such a case is to go with the full blast action plan. I would go with give me packet captures everywhere, over the air, on the Wi-Fi, on the wired side. I want logs. I want to see everything that happens. If every packets of your voice call, I want to see them. I want to see what happens to them, and I want to have a proof where they get distorted or whatever. But that was not possible, right? That was the previous action plans were already too hard to put in place. This one is just
Even worse. Yeah.
even worse. Sometimes I had to go myself on site and conduct those action plans. And actually, when you conduct a Cisco TAC action plan, you can realize how painful it is sometimes to collect that many logs. So it gave me another perspective. But sometimes you just have to do it. You just have to collect.
At some point, you need data, right?
Exactly. But here we could not. So that was out of the question. Okay, what kind of logs can we get to give us any insight with regards to what is happening? The chance we had here is that the wireless client was a Cisco device where we can get logs. If you have a regular smartphone, a regular whatever, handheld scanners, whatever, you're not going to get logs typically.
Exactly. On the third-party equipment, you also don't have the control on that, right? So
Exactly.
you hope that they have some type of debugs, but it's not guaranteed. At least from Cisco product, we know what capabilities they have, right?
Even if there were logs on the third-party client, I'm not skilled to read them.
Exactly.
or know
Yeah.
how to get them.
Might be Chinese for you.
So what did we do here? We collected logs remotely without the users knowing. So those phones, they have a web interface, so you can connect to them remotely and download the logs that they store. So we set the phones to collect the average debug for Wi-Fi and to store them in their flash. It happens that they store around 5-6 hours of logs, so you can have close to a day of work.
Will the battery last with all those debugs on?
Yes. The battery is made to last pretty much the whole day on those phones, and those debugs do not impact the battery life. So that's pretty good.
Interesting.
And they happen to give you the signal strength, so you know how far you are from the access point and the access points that are heard around you. And I look at it, and I'm like, okay, I see some issue. So I'm comforted in this idea that the previous engineer was right, and we might have coverage issue. But the way those logs are taken is just a bunch of files, because the phone writes a file for, I don't know, let's say 10,000 lines, and then it zips it to archive it with the minimum space, and then writes another file. And then it rotates like this, and then creates several zip files. So you have zips of zips. It's
Zipception.
Exactly. It's a zipception. So I had to write a script, and I'm not a good scripter like you, but it's 2023 now. We need to move with the time. So I wrote a Python script that just unzips all the log files and then puts them back in chronological order. So I append every log file to the other, depending on their chronological order. So I have one massive text file with all the logs in it. And then I can parse it more easily and check every time we write down the information of the signal strength. And I could see a lot of problems.
What do you mean with problems?
Moments where the phone didn't have good signal enough. But then I'm like, okay, I need to really do a home run on this one. I cannot start criticizing without having a proof.
Yeah.
So what do? What if we add the telephony logs? We then have the moments the phone is on call, because right now we just had the Wi-Fi logs. We don't know when a call is being placed. So we added just telephony logs, which are very simple. It tells you a call is placed, a call is received, just events like that. And the next day we collected the same logs again, still without telling the nurses, because first, honestly, they didn't want to hear about it. And it's not the privacy invasion. We don't know who they're calling, or we don't know what
you're not listening to the call.
Absolutely. Just getting Wi-Fi data and timestamps of calls.
Yeah, exactly. So you're rebuilding the timeline of Wi-Fi and phone at the same time, correlating those events.
So I had approximately 5 hours of logs, and half of the time, 50% of the time, the phone was on call. The signal was greatly insufficient for proper operations.
In other words, that means it's a bit like when you are in the middle of the forest with your mobile phone and the voice is cutting all the time.
Exactly. Your service provider is going to say, well, that's normal. You're just too far away from our antennas.
Yeah, and that's understandable, but not in a hospital, right?
Exactly, right? So either that points to the design or something happened, but the first worry we had is that if the phone is in a drawer, you can declare, oh yeah, your phone spends most of the time at a low signal strength, but it's normal. If the phone is in the drawer and not in a call, that's normal.
And you don't care because there's no call.
We don't care. Here we care because we know the nurse was really an active user trying to use the device. And half of the time she was on call, she was having issues. So that was bad. And we had 2,000 events of panic scan. Panic scan is what the phone does when it's having a signal so bad, it really stops operating. It stops sending voice and just scans all channels to find an access point, because really it has a signal so bad it cannot send traffic anymore.
Wow, but that's really conflicting with the site survey that was done.
Absolutely. Absolutely. So I come back with this feedback and I'm being told, okay, fine, that may be true, but how come we didn't spot it in the site survey? First problem is I don't do site surveys, because site survey typically requires going on site, and I don't go on site. I know how they're conducted because I kind of know the technology. I get interested, but we have another department of consulting experts who go to customers and do these operations. So we had to look at how the site survey was done to be able to criticize, between air quotes, what happened. So first, I think I have to cover what a site survey exactly is, right?
How does that work?
You could simplify it in saying you just go on site, you put test access points where you think you will put them after the deployment, and you see if the coverage is sufficient. That's how it started 20 years ago. That's what people did 20 years ago, and that's still how people think about it right now. Of course, now there's software, so you can place access points on the map, have a predictive survey done, where you can just simulate what the signal should be. So that at least you get a ballpark estimation how many access points you need, and then you can go on site to verify, because sometimes the blueprints, the maps, don't really tell you how the place physically is. And if you have really large areas, atriums, windowed area where you have leakage between, there's stuff you need to know. So you go on site to verify how thick are the walls, the signal penetrate here or there, etc. You might have places with a lot of metallic machinery, and metal is really bad for waves. It does reflection. So if you have way too much metal...
and that you can't see on the map, of course.
Exactly. All stuff you have to see with your eyes. So it takes a lot of experience to spot all of that. But even then, I would say that's still not what a site survey is. A proper site survey is also, like for any project, you need to understand the user requirement and see if your network is fit for purpose. As vague as that is true. So you might have a very different site survey if you have a stadium, for example. Think about 80,000 fans in a stadium. The density of people is insane, because people are standing right next to each other, and they might all record and send videos via messaging apps. Very, very intensive applications. So there you want to have as much access points as possible to have the throughput, and you lower the signal so that only a few users are on the same access point, and they don't interfere with each other. If you have a large warehouse but with very few clients, you're going to try to have the maximum coverage as possible because very few people would be on the same access point anyway.
So there you would maybe increase the power?
Exactly. Get the maximum power, play with directional antennas to really have the coverage where you want it, and make sure people stay connected as long as possible to the same AP without having to roam to another AP and scan and lose time, etc., etc.
So that's in stadium, that's in warehouses. How do we do that in hospitals then?
Pretty much the same way. So the idea, I would say, is to think, where are the users going to be? What kind of usage are we going to have? Because you might have hospitals where the Wi-Fi is just for guests, for patients to entertain themselves while they recover. You might have hospitals where the Wi-Fi is also used by nurses and doctors to call each other. So there you have criticality coming, and quality of service becomes really critical there. You might want to separate as much as possible the guest Wi-Fi from the hospital Wi-Fi. And then it's 2023, and to be honest, all the hospitals, the doctors, they use laptops, and everyone's laptop now is wireless, right? You just don't plug a cable anymore. So you might have people doing WebExes or other meeting apps. You might have a lot of usage. You might have people transferring large files, X-ray radios. I had hospitals where every few hours the X-ray machine is sending backups of the X-rays it took. And apparently those are very high-res pictures, and that's massive file transfers in one area. So there you need a maximum throughput, just possibly for that device. So you really have to understand user requirements.
So even within a single hospital, you have so many different use cases.
Absolutely.
That you might have to tune your site survey based on the location and the devices and the people that are there.
Exactly.
It's extremely complex.
And I'm not even talking about security, right? You also have a security factor. So there's a lot of things to think about. So a site survey is really an interaction. It's asking questions. It's a Wi-Fi expert asking questions to a network manager who knows all those things, how the hospital operates, but might not think about what it means in terms of technical requirements.
They need really to know the business behind, and in this case, what the nurse are doing, how they are actually using the devices and what they are doing in their day. So it requires a lot of business knowledge, if I can say.
So it's very interesting because you have to use your technical expert knowledge, but translate that in business requirements and have a discussion with people who know the business but might not have the technical knowledge to translate it. And it's really interesting discussions with interesting people.
You need to bridge the gap between the two. Really.
Exactly.
Okay. So
going back to our site survey, right?
Yeah, exactly.
What was the problem with it? They did it with a very powerful laptop adapter. So they had an external adapter on their laptop that did the survey. And that is literally the most powerful adapter on the market.
When you say it like this, it sounds like a good thing, but I guess it's not, right?
It's not. A powerful wireless adapter would mean you can still have good coverage when you're far away from the AP, but that's not what the end users are going to use, right? So you need to be as close as possible to what your users are going to use, which here is a wireless handheld phones. And that has smaller antennas, it's trying to preserve battery. So it's not going to transmit at the maximum allowed power in that country. It's going to try to be reasonable in the power and also try to avoid burning your brain, right? Something different. A laptop is something you hold not so close to you. So they can afford to use the maximum regulatory power, while phones, just for the precaution, people try to have the phone not transmit at the maximum power in your ear, because even though regulations still consider that should not be harmful, at the very best, it's not comfortable to have something very hot in your ear. And we just try to use more reasonable power for things you put next to your head. People don't think about it. The way you hold the phone, if you remember there was a gate type of issue with a certain phone brand. Depending on the way you hold the phone, you put your hand on the antenna and the coverage is really not the same.
You're holding it wrong.
Exactly.
What they were saying.
So think about, you hold the phone in one way and the phone has a line of sight to your access point. So the signal doesn't have to go through your head to reach the access point. Then you turn 180 degrees and then the phone has to go through your head to reach the access point. Your head reduces the signal power by a factor of 2 to 4.
Wow.
That's a lot more talking. If I talk in decibel, people are going to say, oh yeah, it's not that much, but it's literally half the power or a quarter of the power just because your head is in the middle. So it changes a lot. I mean, signal reading from a laptop that you hold in your hands is not going to be affected the same way. So it's really not meaningful. There's a quote from, I actually have no idea who did it, but it's so good, I'm keeping it. Always survey with the least capable, most critical device. So here, what's the most critical device?
That would be the phone.
The phone, because it's voice calls from nurses and doctors that has to go through. That's the most important device for the end user. And least capable, you take the one with the least power, the most restrictions, I would say. So taking a massive laptop with a massive wireless adapter with a full power is the most capable, and that's not what people are going to use at the end of the day. The site survey. So at the end of the report of the site survey, you have a picture of the map and the coverage area. Mm-hmm. And it was all painted green. So you have a color code that says green is good signal, orange is
average.
Average signal, and then either red or no color at all is areas with the signal is so low it's not usable. So you can use different thresholds, etc. But that means already it's a nice picture. But that means depending on the color code you choose, the threshold you choose, you can already cheat a bit. Right? That's one thing. But there was another problem with that. You said, it's all green, but how come? How about we get the original files and see how you did the survey? And that's how we got to involve our consulting experts. That someday we need to get them on the podcast too, because they have good stories. Because they have the experience of using that software for the site survey. And we saw the walking path. So when you do the survey, basically what you do is you go to an area, you tell the software, this is where I am on the map, and it takes the signal reading at that location. Then you go to another location, you say, I'm now here on the map, take the signal reading, and then it's drawing a map based on the data you collected by walking everywhere. And we could see from the walking path, imagine the hospital is a square shape. In the middle of the square, you have just gardens and nothing. But the corridors of the hospital service are square shape, and all the patient rooms are the outside of the square. Mm-hmm. Like, I think a lot of hospitals are like this. They were just walking in the corridors. So they walked the whole square in the corridor and said, signal is good everywhere.
Everywhere in the corridor.
Everywhere in the corridor. Good catch. So what the software does to paint the whole map, because you didn't walk in a patient room, it extrapolates. Oh, if the signal is that good there, I know the average attenuation of just free space, and the software calculates attenuation based on free space path loss. But you guess it's not free space. There are walls, there are doors, there are people, there's furniture,
equipment.
Yes. The map is not that accurate, to have the thickness of the walls, to have all of that was not drawn on the map. So the software was calculating wrong. And because it had not enough data, it just had the data of the corridors.
Yeah.
And then the Wi-Fi, where was it deployed? Only in the corridors.
Not in the rooms.
Exactly. So when they were testing, they were always right under an access point, because there were access points pretty much everywhere. So of course the signal was good when they tested. And it looked good everywhere because of the extrapolation problem by the software, and the walls were not drawn. But basically, where are your users using the Wi-Fi? In the patient rooms. That's where the nurses are. That's where the calls are placed. Nurses are spending most of their time either in a patient room or in their nurse office. And that's not the corridors. But where is the Wi-Fi deployed? Only in the corridors.
Seems like a disconnect, right?
Right. I'm not blaming anyone. It's a disclaimer I forgot at the beginning, because everyone involved was really good and knowledgeable here. And it's a restriction from the hospital, right? The hospital refuses to deploy access points inside the patient rooms for aesthetic concerns, for health concerns. Some people might not want to have Wi-Fi close to them, even though I guarantee you there is no health issues. But people prefer to have the APs in the corridors. That's just a fact of life. Mm-hmm. But that leads to a problem. That's not where you're using them. So you're always far away from an access point when you use it. And if the patient room door is closed, in most hospitals, the door is super thick. Yeah. And that plays a lot of role. So if the door is open, that changes the game a lot as well.
So we know that coverage appears to be the problem, but given the restriction you mentioned, we cannot put access point in the rooms. What happened next? What did you do?
Well, I broke the news. People started to believe me, but they still had a concern. How come it's a new problem? Because we didn't have the issue before, right? And this refresh of the network they put things, the APs are exactly at the same place the previous ones were. So that should not change, right? And they were still not buying my explanation. They said, okay, we believe it is a signal problem, yes, but it's probably because your new hardware is not good enough because we didn't have the problem before. So before implementing any solution, which implementing solution was still also a challenge, but we need to still keep convincing. So how can I go back in time and
proof that it was or was not good at that time, right?
I already cannot take logs now. How can I take logs 7 years back? But we do have a knowledge database in Cisco, right? So I thought maybe this hospital already opened a ticket before their refresh, and maybe we still have that data. And that actually was the case. So I found a ticket open for a completely unrelated problem, but the equivalent of a showtech for wireless was attached there. And we have the configuration, but we also have a lot of metrics and data there. So what do we find? Something I forgot to mention, all the APs right now are already at their maximum power. So the algorithm, which is smart and chooses the power, said, the coverage is so bad, I have to put everything at the maximum power because otherwise it's going to be even worse. That was another hint. That's actually why the very first tech engineer suspected coverage could be a problem. And 7 years back, all the APs were still at the maximum power. And the maximum power is the same in milliwatts between those two hardware models. There is no difference at all. So I had the proof that already 7 years back, the APs were at their maximum and were trying to go higher, but they couldn't. Another hint we had in statistics, there is a general statistic on the wireless controller of how many % of your clients, it's now called the health core in the NS Center. That's basically how many % of your users are connected far away. So we don't know if they're far, but they're at a very bad signal, typically because they're far.
They have one bar of signal, something like that.
35% of all their clients were having a terrible signal that does not allow you to properly send voice traffic.
Wow, that's huge.
Already 7 years back.
7 years back. So not a new problem for sure.
Exactly. Then I was asked the question, but how come people didn't complain before? And that's where, I don't have a crystal ball. That I cannot answer. I don't know.
It was not COVID time for sure. So maybe the pressure on having good, reliable communication was not there.
Exactly. So a lot of things could have changed. Maybe they had another phone system. Maybe they had DECT phones back then. A lot of things could have changed. Possibly something I noticed, some places, some hospitals, some offices, they have windows. And if you have a special type of windows or even like a plastic film on them, that can block the waves. And that can be done on purpose to not have people spying on you, etc. So it could be just a refresh of the hospital windows blocked cell phone coverage from entering in, and before people use their own cell phone, and now they have to rely on the hospital internal solutions. What do I know, right? A lot of reasons could be there to explain, but because I'm not there physically for the last 7 years, I cannot reply. But okay, there must be an explanation.
Wow, but that's crazy because you've discovered that the problem was always there. Yet that's still a problem. So was there a fix for this?
That's the part that hurts. So the proper fix is to do another site survey, but correctly this time. So do a site survey with the end user device. Here it's not actually possible, right? Because it's a phone, so you cannot use the software. But those professional tools, they have a simulator. So you compare the signal reception by your laptop and the client device, and it's going to notice the difference. So, okay, this wireless phone seems to be 5 decibel, 10 decibel less capable than my laptop. So it compensates for that. It kind of simulates being the least capable, most critical device you have. And then you have a proper signal being shown on the map. Second thing, you cannot enter patient rooms. Okay. So either you have to draw the walls on the map so the software can simulate how the signal will be inside the rooms properly, as good as you're going to draw the walls and doors and all the furnitures. That's one possibility. Or that takes permission, but I guess it's feasible that you have sometimes empty rooms and you enter those empty patient rooms to take signal measurements there, and then you can extrapolate in other rooms how it would be. At least you get some samples of, I'm in this room now, I close the door, this is how bad it is. It's a small reality check, right? And possibly you can combine all of that to have a good picture. So that was done. The problem is it recommended having 30% more access points to cover the hospital, which, is already a lot of budget to purchase, but also we were ready to help the customer with a commercial gesture, but you still need to install those access points. So that's a lot of manpower to go there and install the access points.
And still during COVID.
Yes, the COVID was not finished. So that was ending in 2021. Still COVID was there. The other problem is the more Wi-Fi you have, the more cables you need, because you need to plug those access points in switch ports.
And the more switches you need probably as well.
Exactly, because they were already maxed out on their switches. And power budget, because access points use PoE. So you need to have proper PoE budget on your switches and have more switch ports. So more access switches means also more core switches, at least switch ports. So a complete network redesign needed to be done.
Wow.
And that's not even mentioning where to place them, because you don't just add access points anywhere to fill the gaps. You need to redeploy them so that the coverage is even, right? It's 30% more, but with another placement logic. And that requires replacing all of them.
So it's a bit of gerrymandering of access points.
Exactly. That's exactly the word, yes. So that's the solution advised. And that took a long time to put in place. To be honest, I think it's still ongoing. So it's been done areas by areas, and the situation is much better in areas where it was done. But users are still suffering in areas where the refresh was not done yet.
Wow. It's really a crazy story here, because we are talking about, technical problem, but related to a physical environment, like physical space, and the use that the people are making with our devices, and things that are mostly invisible from in the logs, in the show command, in whatever data that we can collect. So it's really, what amazed me in this story is like how you had to understand the business, like the day-to-day work of nurses and doctors, all of that to come up with a proper solution and actually a proper site survey to identify all those gaps. That's really crazy. It's amazing me.
Yeah, and that's actually bringing several conclusions. How to do proper site survey, etc. Understand your users' requirements, yes. But how about reviewing your design every few years, right? Because a lot of people say, oh, can we do a one-to-one replacement, right? We just buy new switches, we buy new access points, we just replace the old one with the new one and we're good to go. And they know that they should do a redesign, but it's, how bad can it be? But then the question is, the last time you did a refresh, did you also do a one-to-one replacement without rethinking your design? I have some customers that, the last time we did a design study was in 2000, right?
Wow.
And we just kept refreshing since then. Like, maybe you need to, reconsider, because the type of traffic in your network is completely different. Usages have changed a lot in 23 years. So it's going to be different for everyone. You might say, I don't think my requirements changed. We've been a stable business. We use Wi-Fi, just for anecdotal purposes. If you know it, that's fine. But just think about it, right? Take the time to think. Is it really worth it? Shouldn't we do? You don't have to do a full redesign, but just come back to the table and say, what are our requirements? Have they changed? How would it impact our network, etc. And also, you don't always have the budget to invest now, but think about the future, right? What's your business going to be in the next 5 years, and how can you already prepare it? Because without necessarily purchasing brand new equipment ready for the future, already doing design choices and config choices that makes it easier in the future to adapt there's no time to do that. It's always right now is the good time to think about the future.
Indeed. And especially if your critical business needs to go through communication like this, it's really important that you focus and make sure to redesign that periodically, make sure that you update everything so that you don't end up in those type of situations, I guess, right?
Exactly. Another thing that strikes me is this could have been stopped by everyone in the middle of this process. The engineers who went on site to try to reproduce the problem could have noticed that they were only allowed to walk in the corridors and not allowed to test in the patient room. And maybe when the nurse complains, it's mostly in the patient room that it happens. Maybe that person noticed it, but that feedback was not raised to the management people who were doing the escalation or to me. So it was lost. The people who did the site survey also, they were blocked to enter the patient rooms, and they could have noted it in the report. This site survey was done to the best of our ability, but may not be representative because we were not allowed to enter those areas. And this way, it's a good disclaimer, right? For legal purposes, you did your job, but you were not allowed to do it fully. So you disclose that it might not be perfect. At every step, people could have raised the flag that there is this limitation, this requirement. Maybe that's causing a problem. But because there's pressure, because there's always management restrictions, this and that, people just didn't say anything, and that costs a lot of money.
In other words, speak up if you have a doubt or if you want to raise a point.
Exactly.
I mean, there is no such thing as a stupid question or remark. I guess if you want to say something, say something. That would have probably saved a lot of time, right? And money.
Exactly. I was taught to always, you can speak up, but do it constructively, right?
Yeah.
So you can say, well, we did the job, we did everything we were asked. I have this concern. Maybe it's not representative because of this and that. I please want to have it noted down. And no one's going to complain that you did that, right? Like it's doing your job to actually to raise this flag. So that's important. And on the same area of costing money, I was lucky, to be honest, that the few tests I did put me on the right track, right? We have cases where we struggle a lot to find a solution. But think about the time and cost it was for me to get those remote logs and prove that the coverage was insufficient, to prove something I forgot to mention, also QoS, quality of service, was not in place. The previous engineer asked, do you have quality of service in place? And they checked the configuration and said, yes, we configured it. But no one validated that it was actually operating properly in the field. So just by monitoring one phone call randomly, I could see coverage is insufficient, and the quality of service configuration must have some problem because it is not in place in the field in the captures. And because this validation after the deployment was not done, would have taken half a day when the network was deployed to validate that all is well. This escalated. Everyone had to do on-site visits. The hospital lost a lot of time and frustrations, all those calls lost. The partner engineers had to go on-site, and more complex troubleshooting was done because the first sanity check validation was not done. So I can't think of insisting more on basic sanity checks. Every time we have a case, we have bad voice quality, I'm like, okay, step one, is your coverage sufficient? That's easy to check. You just walk around, check if you have areas with low bars. Not rocket science. Anyone can do that. You just teach anyone, this is what you need to look for, they can do it 10 minutes. And you also have easy markers to know if quality of service is in place. And if all of that is in place, for sure, you have a very specific issue. You could have a bug or whatever, but it's going to be it's going to be in specific conditions with a specific trigger. We can work on it, get debugs, etc. But if your issue is all over the place, just calls are terrible and we can't isolate it, it's all over the place, you missed something larger, something more basic.
It must be obvious, right?
Exactly.
Mm-hmm. Cool. Thank you, Nico. It was a hell of a story, really. So thanks a lot for telling it to us. It was good learning for me. I learned a lot about site surveys I didn't know about, so thanks for that. I do have one more question for you. As you know, we like to do a technical question on your technology area of expertise, and you are obviously in wireless. When we talk about wireless technologies, there is Wi-Fi, obviously, but there are others. And for example, 5G is one of them. And we hear a lot about 5G and Wi-Fi like converging or acting together, or things like enterprise 5G. So how does that work together? Is there going to be like a single solution to rule them all in the future?
Never. So there are several things. There's many protocols, many solutions that fit many areas. Wi-Fi is in the niche where it's cheap, where it's somewhat open. Everyone can implement their own chip, and it's made to connect anywhere. So the original concept was you can go to anyone's place, any hotspot, connect to any network, and it's free and it's fine. And that was the simplicity in by Wi-Fi in the beginning, and to have somewhat high throughput. So we're improving on reliability a bit. We're improving throughput. We're improving collisions, etc. 5G is filling another market. It's usually much larger coverage because you need to cover an entire country. It's managed by service providers, and it's therefore not free and never will be. So you have there your main differences. In the future, I'm not saying one technology is better than the others. They have different objectives, right? They overlap a bit more and more than before, but they really have different markets, I would say. With Wi-Fi, you manage your own network. You own the network. The data stays on your network. With 5G, you have a service provider, so you own nothing. You're just the client. I'm a Wi-Fi guy, so maybe it sounds like I will talk bad about 5G, but I'm going to catch up afterwards. 5G uses more battery. So equipment with a 5G modem are usually more expensive. You can notice it with your smartwatch. The Wi-Fi model is usually cheaper than the 5G or 4G model before that. It requires to have a SIM card, so you need to budget that as well with your service provider.
And a subscription.
Exactly, right? While Wi-Fi is cheap, completely free, and doesn't impact your battery that much. So now there is a new concept of private 5G, which is not necessarily there was private 4G as well. It's not about the 5. And that's also coming with enterprise 5G. So what is that? It's really owning a part of the network. There are frequency bands. So the 4G, 5G, all the cellular basically, those are licensed bands. Frequency bands you cannot, as an individual, operate on because it needs to have a license from the government. That costs a lot of money, which is also why service provider reflect this cost. Those private bands are free for use, but you have to register. So there's still control in the sense that not every random person can use and abuse it. You're not going to be able to use it in your apartment and bother your neighbors with it. But if you're a company, if you're a factory, you can book that license in your area as long as it's registered in a central database and the authority verifies that you're not impacting anyone else. So it's a mix between unlicensed and licensed where you pay to be the only one. Here, you're not necessarily paying. Might actually vary in some places. But you're still like not anyone can just come up and fire up a device on that frequency. Like a hacker could not just fire up a device on that frequency without registering themselves also with the authorities, which the hacker will obviously try to avoid. So what does that bring? It brings more control because you can own the 5G network, right, as an enterprise. And you also own, partially at least, the frequency. So that brings advantages over Wi-Fi is that it's not unlicensed. You cannot have random people coming using your frequency bands. So your frequency bands are booked. They're more controlled, less interference, no interference at all, typically. Because of the technology, it covers larger areas. So you can cover 1 kilometer, 2 kilometers, which Wi-Fi can reach, but in very specific cases. And you have, because of the protocol being very different, Wi-Fi is more open to anyone. Anyone can speak. Cellular is more, there is one boss, and the boss says who speaks. So the antenna, the base station is saying, you, client number 1, you can speak. Now it's over. Client 2, now you speak. And there is no collision because the antenna is there to be the boss and say who has the talking stick, right? It's a talking stick system. It's getting more and more complicated than a talking stick right now. Several people could even talk at the same time, but okay, that's
different story.
Yeah. But still, the antenna, the base station controls who speaks. And while in Wi-Fi, it's a free-for-all. It's a war. You just speak first, you win. Which has its advantages and its problems, right? So it's two different philosophies. And I think 5G or private 5G is going to be really coming on the market for industries, like they call it Industry 4.0, really connected factories, mining environment. So all those companies, they have several kilometers. They operate over several kilometers. They have autonomous trucks. Actually had a customer, it was a mining company. They have self-driving trucks, GPS guided, and there's literally no one in the truck, and they go pick up load and go drop them where they need, etc. It's really amazing stuff. And that is very easy and cheap to do now with Wi-Fi, but Wi-Fi is not 100% reliable. Like you might have glitches.
Especially on large distances.
Exactly. And then it starts to cost more because you need to put access points everywhere. So you might want to have fewer 5G antennas, just cover your whole place. And because you don't need a lot of throughput, you don't need, you're not streaming gigabytes of videos or transferring large files. No, you just have to control your forklifters, your trucks, your devices, and you just need to have control and sensors and reporting. Like you can do a lot of stuff, but it's usually not high throughput stuff. But quality of service and control are really the key factor. And 5G solutions are quite more expensive right now, private 5Gs. So Wi-Fi is still winning on the cheap side, but I think that's going to slowly converge. But I still think there are going to be different use cases. Tomorrow, you're not going to have a 5G SIM card in your laptop. You're still going to want your laptop to be able to connect to any Wi-Fi network. Wearables, all those smart devices, they're going to be preferably Wi-Fi, because then you can have one internet subscription at home and not 10 SIM cards, right? I still think that's how it's going to go for the next years. But for sure, they're coming a lot closer than before.
Wow, that was very interesting, actually. So thanks a lot, Nico. That was great to hear from you.
My pleasure to be here.
And speak to you next time. Thank you.
Thank you. Bye-bye.
Thanks for listening to this episode of Cisco Tech Stories podcast. We'd love to hear your feedback, so reach out to us on Twitter at Cisco Tech Stories. Our music is produced by our multi-talented Chris van der Kruis.
Next time on Cisco Tech Stories.
But the strange thing is that on all the devices where we increased logging, we were never able to catch the problem. They just kept working after we increased logging.